All right, friends and neighbors, welcome back to this chapter 19 of CCNA Volume 2, Understanding Ansible, Puppet, and Chef. This is a significant one because it's the last chapter in the CCNA. So in this video, we'll hit the key topics of the last chapter. Exam section that we're after right here, we're still working with the automation and programmability, but this time we're going to worry about configuration management. So there are a bunch of things that we want a configuration management tool to be able to do for us. So this will be recognizing the capabilities and configuration mechanisms of Puppet, Chef, and Ansible. And first we'll talk about, what you want in a configuration management tool, and then we'll quickly hit the basics of all three of those. And then the do I know this already questions. So the key topics in this particular chapter, issues that arise from configuration drift. And we'll talk more about what configuration drift is. The chapter has samples showing router configuration file differences with GitHub. But really that's just doing a diff on two files, right, to show you what changed. So I didn't include that in this video. The basic configuration monitoring concepts, we'll talk about all of that, right? What do we want the minute we have a lot of things to manage? So primary functions of our configuration management tools. We'll take a quick look at template and configuration file example, and then we'll talk about what templates bring to us. And then again, we'll talk about the three different tools that are, sort of seeing the most use today. So if you're working towards your CCNA, certainly at this point, you've built configs, and we've done a lot of stuff in Packet Tracer together. So you know how to build a configuration. And back when we were talking about files and the iOS, the operating system itself, we know how to manipulate the file systems and how to save files on it. So the really basic thing that we might do is copy, run, start, right? Copy the running configuration to the startup config so that if the device reboots, it comes out on the configuration that I want rather than its default configuration. Okay. But what if you had hundreds of devices to configure? Would you want to reach out and touch each device and manage it and then save a local file, right? So now you've got configuration files that are not only managed by you or somebody else, but managed manually, but every device has its local configuration file. And to understand what's happening with the device, you would have to connect to it. Well, that's a lot. That's a lot to manage. Now let's throw in other things like what if there are multiple folks editing the files? What if a device goes down and we lose a configuration file? So there's all kinds of issues associated with managing devices when the number of devices gets really, really large. Now there is a thing called the golden config, the ideal config, right? The one that you want all the devices to have, particularly devices that are fulfilling the same kind of role, right? The chapter uses the branch router example, but this might be switches in the same location or fulfilling the same role. It could be just about anything. So how would you manage all of that stuff? Now these issues, right, all of these challenges are why organizations invest in configuration management tools. I mean, it's fine if you're the only one managing a branch office and you know where everything is and you're the one that manages all the configuration changes, fine. You can, copy and paste everything into text files and save it on your machine. Okay, but if you've got a lot of devices or a lot of people, or we have, a high change environment, so this is where a configuration management tool can really help you out. And it will include the historical data, who made the changes, timestamps. So revision control. Revision control is really important in almost any system. Well, what do we want to be able to do? Well, at the sort of base level, right? If you just say, all right, we're going to try and solve some of these problems, you want a centralized configuration file and version control. So if I've got a bunch of switches that are all doing the same thing, a bunch of routers that are all doing the same thing, then I'll have a centralized repository with the configuration file. And when anybody touches it, we save another version of that file and we know who did it. So we can ask questions, and so we can do some rollbacks and things like that. So that helps prevent what we call configuration drift. Now, configuration drift, you can look at it a bunch of ways. There's actually a question in the chapter on it. But essentially, it is, okay, you've got a bunch of devices that are fulfilling the same role, and they're all supposed to have a configuration that looks like, X. But some of them have a configuration that looks like Y. And so that there's a delta there, there's a change. And that change is the configuration drift, especially if we don't know how we got from X to Y. We don't know who did it or when or the reasons why. So the centralized control allows us to understand what's going on when there are configuration changes. There's also a backup, right? If we get a corrupted or lost file, if we're onboarding a machine, you can put out that golden config out there or the ideal config. Now the team will decide on where the best answer lies. So if you've got a configuration and you've got the centralized version, and then for some reason there were changes that were made in, say, a branch router. Well, there might be a very good reason for that, and so you might decide that that's the version you want to keep and update the central one. Or you might say, well, wait a minute, that's supposed to have what everybody else has, so we're going to make this the one that we push back out to the branch router. But as a team, you decide what your source of truth is going to be. So that version control and the ability to compare files to see what changed and why, that was really, really important. But the next idea is configuration monitoring and enforcement. So now you've got your configs all pushed out, and then there is a change. We want to be able to know, A, that we can push configs out, but also if there was a change, that it happened and who did it and when. So you're monitoring changes in drift, right? We want zero drift, and now there's been a configuration change. And then if we need to, we can roll back or we can update our configs based on whatever that change was, but we want to know that it happened. And then the configuration provisioning stuff is that ability to push configurations out. Now we have this model in lots of places. If you worked with wireless gear recently, you know that we have the wireless controller. Now this is also a nod to the software-defined architectures that we've been talking about, but you've got a controller that manages hundreds of access points. It used to be that we would go out and touch all of the access points to give them their config, but now the controller just says, yep, this is who you are, this is your SSID, this is security tokens, here's all your stuff. And so it's really, really great to be able to push that out. And when you add devices, you can easily get them integrated into the network and so on and so forth. So that configuration provisioning is really, really important feature of our configuration management tool. All right, so you got a bunch of devices and you're getting ready to push things out. So let's say you've got 100 devices or 1,000 devices. If you have a centralized management tool, then you could theoretically have 100 or 1,000 configurations on that device, and you were able to push them out and then monitor them. Well, that's one way to go, but that's not a huge improvement over having to go to the individual devices themselves, right? You still have to change 100 devices. You still had to touch them remotely via SSH or something. Yeah, you had to actually get on the keyboard for each one. A better way is to think about the use of templates. So if you have access points that are all doing the same job, or switches that are all doing the same job, or routers that are doing all the same job, then there's no need to have, say, separate configuration options for each one. What you have is a template, and you say, here is my core switch template, and here is my branch router template, and here's my access point template. So the template gets applied to everybody, and the template has variables. So in the example above me here, host name, address, and mask are all examples of variables. And so now what you have is configuration files that fill in the variables for that. So this example is for use with Ansible. So this is a Jinja2 or Jinja2 template, and that has the base configuration for all the devices in the same role, but the variables are filled in. And then the YAML file will fill in all the variables. So the two work together. So the template takes as input this YAML file, fills in all of those, and then pushes the config out. So now all that I'm worried about is what's actually different between the devices rather than everything. So the templates contain the variables and then we push them in, or they're read in from a YAML file. Now, as part of this, your management tool also defines when you're going to make a change, what change to make, and to what devices. So you don't have to blast it out everywhere, and it's not, a one-size-fits-all kind of thing. Now, as you can see, there's some formatting here. So each one of the tools that we're going to talk about has sort of its own language. And I put language in quotes because it's a formatting thing. It's a way to recognize the variables, right? We know that the REST and YAML and XML all have their basic formats that they use to read stuff in or to organize things. So first up, we'll tackle Ansible. Right? You can go out to ansible.com. Now, all of these, Puppet, Chef, and Ansible, all have free versions, and they all typically will run in a VM or something like that. And there are some differences between them, though. So from the Ansible website, Ansible is an open source IT automation engine that automates provisioning, configuration management, application deployment, orchestration, and many other IT processes. So that's what we've been talking about, right? Now this is agentless, which means that you're not going to have a separate software instance running on your devices to ask for the config, right? So what Ansible does is you build the configurations and you push them out. And so you have to have a valid connection, and there's no additional code that's necessary on the devices themselves. So create the files, push them to the device. Now Ansible also uses what's called the imperative model, and that all steps to completion are defined. So we have to do this, then we do this, then we do this, then we do this. And these two things, agentless and being imperative driven, are probably some of the biggest differences between Ansible and Puppet and Chef on the other side. So the language for Ansible, you have playbooks, the actions and logic about what Ansible is going to do, all that scheduling and everything else. The inventory, this is all your hosts, their names, their individual details. And then the templates, those are going to be the Jinja 2 formatted files with variables. And then the variables themselves, that would be the YAML file that we use for each individual device. So that's sort of the Ansible language. So Ansible's running in a VM. You collect the data about your network, you build your YAML formatted files, maybe some templates, and then you build your configs and push those out. So that's Ansible. So the definition from Puppet, right? Intelligent infrastructure governance. Okay, so it's all the same stuff that we want from a configuration management tool. The big difference here is that the Puppet Master is the one that's running the show, but this is a pull model. And so if you look at the image above me here, right, there's this agent that's sitting on here. So here's an agent that's actually sitting on the device, or maybe a proxy agent. Puppet has the ability to run with an agent or quasi-agentless. And this is declarative, meaning that we're here in a config and we want to get there. Please figure this out for me. So the language in Puppet is that there's a manifest, the Puppet formatted device configuration file. And then I've got these sort of organized as module, class, and resource, because the module is the larger object, and then we got classes, and classes make use of resources. And these are all components in the manifest, similar to the template that we saw earlier. And the templates are just formatted for Puppet. So the idea here is that this is a pull model now. And so imagine that you've got Puppet code running on your routers or switches out there in the world, and they're talking with the Puppet master. And so the agent facilitates the configuration change. And this is one of the reasons why you have to be a little careful with both Puppet and Chef, because you're not sure if there's support for Puppet code on your devices, which is why there's a Puppet proxy agent model out there. Now, both Ansible and the Puppet proxy agent will use standard connection types to talk to the device. So that might be SSH, for example. Now, our last one here is Chef. Chef does the things, right? All of the configuration management or management ops that we expect from these tools, but it's similar to Puppet in that it's got an agent. And it doesn't have the proxy agent model. So this is again a question of whether or not your devices are going to support this. Now, whether they're changing that for Chef, I'm not sure at the time of this video, but the challenge noted in both the book and in their current offering is that it's going to run the agent model. Now, the language of Chef is kind of fun, right? It's all kitchen based. So there's the resource, the objects to be configured and managed by Chef, but then you've got your recipe, what you're going to do, right? How, when, and where. You got your cookbooks, is the set of recipes that might go together, set of device configuration files that might go together, and then the run list as to what you're going to do when it's time to make use of your cookbooks or your recipes and your resources. So there we go. There's the difference between the big three. Of these three, they can sort of be organized into whether or not you've got an agent or no agent. All right, do you know this already? Do I know this already? Which answer best describes the meaning of the term configuration drift? Well, the book says that C, challenges over time with respect to devices in a similar role, but you could also say drift is the difference between the difference in any configuration change, right? It's supposed to be this, it's this over here, why is it over there? But the book makes a distinction between that and devices in a similar role. Question number 2, an enterprise moves away from manual configuration methods, WISE, making changes by editing centralized configuration files. Which answers list an issue resolved by using a version control system with those centralized files? Remember that a version control system is going to give you when changes were made and who made them. So A and B, the ability to see who made changes and what they were when the changes were made. Question number 3, configuration monitoring, right? Keeping track of your configurations, also called configuration enforcement, by a configuration management tool generally solves what problem? And that was D, finding instances of configuration drift. And so you push configurations out there, and your monitoring is going to check on things to make sure that things haven't changed. So it's a periodic check. And so you go, aha, something's occurred. We've got some drift happening. Question number 4, which of the following configuration management tools uses a push model to configure network devices? And that was A, Ansible. The other two are pull models, right, with their agent. And Ansible will use either SSH to get that done or netconfig or something like that, whatever you're using in your systems. Question number 5, which of the following answers lists a correct combination of configuration management tool and the term used for one of its primary configuration files? Choose 2 answers. Well, that was B and C, the Puppet Manifest and the Chef Recipe. Ansible has the playbooks. Well, we're going to do a review look ahead. We're done with chapters, right? So we're done. This is done with volume 2. We'll do some review and then it'll be time to take the test. I think what I'll do is put together all the questions for you and then we'll break them up maybe into two volumes. And that'll be it. Hopefully you're getting ready to take the tests. I'll take the test and we'll see what happens. Okay, that's it. This has been a look at configuration management tools and Puppet, Chef, and Ansible basics, right? So we talked about configuration management challenges, and the big one there is configuration drift. Everybody's touching it, changes over time, things of that sort. And then techniques to manage all that, right? Centralized management, revision control, keeping track of things, the ability to push things out. Agents versus no agents, right? We know that Ansible does not have an agent where Puppet and Chef do. The recipes, playbooks, and manifests. What files are we dealing with? What sort of configuration tools do we have at our disposal, and how do we build things and put things together? Well, that's it. That's it for the CCNA series, except for the review videos that I'll put up. So like and subscribe if you enjoyed the series. And if you're getting ready for that exam, may those packets always reach their destinations. I'm confident. We've done this together. You can do this.